Hi there, this is video 718. We're going to do y-intercepts. With the previous video, we looked at concavity. Let's flip my page here, and maximum minimums and equations and domain range. We didn't talk about the x and y-intercepts from doing that from analysis. So let's take a look. Kind of going to do this slightly different. First thing, and most important thing to remember is there is always only one y-intercept. Don't be looking for two. Every single graph should cross the x-axis somewhere. But instead of me telling you the rule, I would like you to take a look at, don't worry about the equations up there for now. Look at all these graphs and write out what the y-intercept is. You can do that now. All right. So you could also, if you don't like the graphs, highlight the axes so it's easier to see. Okay, so we want to know where it crosses the y-axis. So that's this one, and there's my graph. So that's going to be 0 and 3. Don't be lazy. Intercepts are always points. All right, let's find this one. There it is. So that's going to be 0 and minus 1. And there's that one. So that's going to be 0 and minus 2. And this one, oh, looks like it's going to be 0 and 0. Now, I want you to take your answers here and look up at the equations. And what do you notice? Isn't that nice? Look how sweet that is. So when your graph is in the standard form, really, all you got to do is look at the constant, the value of c, and ta-da! You already know what the y-intercept is going to be. Oh, on this one, right? You can always add the plus 0 to it. So we're good. So what do you notice about two things? So one, the x coordinate is always 0. And for these specific ones, and this is going to be sad because it only works on these ones, if, if the equation is in standard form, y-intercept is c. Done. Easy to read right off the equation. Okay, so let's see what happens when we have something in the vertex graphing form. Let's do it the same way. Let's look at the graphs first. So oh goodness, those are pretty tiny. 0 and 8. Can you do the other three? And that's going to be, it looks like 0 and minus 7. I'm going to put a little star there because I can't really see. I think that's what it is. And then we've got 0 and minus 3. And oh goodness, they're all minus. I got 0 and minus 5. Okay, now we were so excited about up here how this matched. Well, that just fell apart. It doesn't work. But there is a way to find the y-intercept, and it's not particularly difficult. All you have to remember is the y-intercept, x is equal to 0. All right, now I'm going to explain why there's this picture of this handsome young man at the bottom of the page. That'll be my son, okay? And this is going to be one of those things that's going to help you remember stuff. So when confession time, when I was in university, I was chasing a guy named Eric. Just an emphasis on chasing. I never went anywhere. I didn't get anywhere. Okay. X number of years down the road, I find a wonderful guy. I get married. We have a kid. He says, I want to name him Eric after my uncle. I'm like, okay, which is fine. I mean, his name is Eric, named after Henning's uncle. But for the first 6 months of my child's life, when I was at home with my family and introducing my son, it was his name is Eric, not named after that guy I chased in university. And everybody I introduced him to, this is Eric, not named after that guy from university. Every single time. Because they were all looking at me going like, seriously? What are you doing? Well, there's a point to this story. What I need you to do is your brain needs to say y-intercept x equals 0. Every single time you write x-intercept, you're going to now go, y-intercept, you're going to write x equals 0. That's all one. Just like Eric, not named after that guy from university, y-intercept x equals 0. It just comes. It's a total name. It's a complete name. You do it every single time. Okay, just saying. Because now this becomes really easy. What you do is you substitute. So y is equal to 2x plus 3. I'm just copying this. Squared minus 10. And if we're doing the x-intercept, I'm saying it backwards. Y-intercept x is 0. So y is equal to 2 times 0 plus 3 squared minus 10. Y is equal to 2. 0 plus 3 is 3 squared minus 10. Y is equal to 2 times 9 minus 10. Y equals it, yep, is equal to 18 minus 10. Y is equal to 8. So 0 and 8. Not nearly as pretty as up here, where we could just read it off the graph, but it's not that hard. Let's do one more. So y is equal to 0.5 x minus 4 squared minus 15. So y is equal to 0.5. So we're doing that. Y-intercept x is 0. You just plug it in. 0 minus 4 squared minus 15. Y is equal to 0.5. 0 minus 4 is minus 4 squared minus 15. You see why we spent so much time on order operations at the beginning of the year, right? You got to know this stuff so that when you come to new stuff, you're not having to relearn it. Y is equal to 0.5. Okay, so negative 4 times negative 4 is 16 minus 15. 0.5 times 16 is 8. Y is equal to minus 7. So what you got? 0 and minus 7. So I don't honestly know which would be easier if I had to find the y-intercepts, whether it would be faster for me to just graph it and find the y-intercept or to calculate it. The nice thing about these being able to do it this way is if you had some crazy graph with a really big y-intercept of like 40 or something like that, it would pretty much be impossible to graph. But by calculating it this way, we're good. And I'm just going to bring one of the equations from up here. So I'm going to go y is equal to minus 10 x squared plus 6x minus 2. So this is not in the vertex graphing form. This is in our standard form. And you know right away the answers to, but let me show you. This is the cool part. I'm going to go y-intercept x equals 0. So y is equal to minus 10 times 0 squared plus 6 times 0 squared minus, whoopsie, not a squared on that, minus 2. So y is equal to 0 plus 0 minus 2. Y is equal to minus 2. So my point is this. If you're doing the y-intercept, you make x equal to 0. It'll work no matter what your equation looks like. So if I'm going to remember 1, this works whether it's in the graphing form, the vertex graphing form, or the standard form. It always, always, always works. So I think it's the more powerful of the two. If you remember that when it's in this form, you can just read it off. Good. That's awesome. But if you just remember that you just substitute y-intercept, x equals 0, it'll work for you every single time. All right, cool. End the video.